Hey guys, welcome back to another video. In this video, we're going to solve another question related to intervals, and that question is insert an interval. So we are given an array of non-overlapping intervals, and every interval has a start and an end, and these intervals are sorted in ascending order by their start values, and we are given a new interval, and we have to insert this interval in this array such that the final merged array of intervals is also sorted by start values and is also non-overlapping. So for example, if we are given an array, let's say first interval is 1, 3, second interval is 6, 9, third interval is 12, 15, and we are given a new interval, let's say 4, 7, and we have to insert this interval in this array of intervals such that the final array of intervals is also sorted by start values and is also non-overlapping. So if we want to insert this interval in this array, the final resulting array is going to look something like this: 1, 3, and this is going to be 4, 9, and final value is going to be 12, 15. So as you can see, this value 4, 7 has been merged with this interval 6, 9. So let's try to draw 6 and 9. Let's say 6 is here and 9 is here. So 4 would be somewhere here and 7 would be somewhere here. And the merge of these two intervals would look something like this. We'll have to find minimum value of 4, 6, which is 4, and maximum value of 9 and 7, which is going to be 9. So final interval is going to be 4, 9, and the final resulting array is non-overlapping and sorted by their start values. So this is non-overlapping. So what non-overlapping means is for two adjacent intervals, the start value is strictly greater than end value of previous interval. Before solving this question, I highly recommend you to solve merge intervals problem, because we are going to use a similar approach that we used in merge intervals problem, and we are going to use two-pointer approach to solve this problem. So let's dive into the algorithm to solve this problem. Let's say we are given this example, and in this example we are given four intervals and we have to insert an interval 10, 13 in this array of intervals. So for our two-pointer approach, we are going to create two variables. So the first variable we can create is we can create a current interval variable and assign it to our new interval that needs to be inserted in this array of intervals. And another variable interval is going to iterate over our current array of intervals. And now let's see what we can do with these two intervals, current interval and interval. So as you can see that this interval 1, 3, its end value is less than start value of 10, 13. So we can simply add 1, 3 to our new array of intervals. So we simply add this and we can increment our I variable, and our interval is now going to be 6, 9. And now again the end value of 6, 9 is less than 10, 13. So we can simply add 6, 9 to our new array of intervals. And now we move on to the next interval, which is 12, 15. So here, as you can see, 12, 15 overlaps with 10, 13. So newly resulting interval is going to be 10, 15. And we are simply going to update this current interval variable with these new start and end values. So we update this start value with the minimum of 10, 12, which is 10, and the max value of 13, 15, which is 15. So this 13 is going to be updated with value 15. When there is a merge, we simply update the value of current interval. And now we move on to the next interval, which is 17, 20. So this interval variable is going to be 17, 20. So here, as you can see, now our interval start value is greater than the end value of current interval 10, 15. Now what happens is we can simply add this current interval to our new array of intervals. So we simply add 10, 15 here. After adding 10, 15 to our newly array of intervals, we are also going to update this value of current interval. This now points to this interval 17, 20, and now we increment I. So now I goes out of the bounds and we are done with iterating over our original array of intervals. So our current interval points to 17, 20. So after we are done with iterating over the array, now we are going to add this current interval to our final list. That is going to add 17, 20 to our final array of intervals. So this is going to be our final array of intervals, and at the end we can simply return this and we will be done. So basically we are doing 3 checks. The first check is whether this interval comes before current interval. If that is the case, we simply add this interval to our final array of intervals. And second case is when there is an overlap, we update the value of current interval and move on to the next interval. And for the third case, when current interval comes before interval, then we first add current interval to our final array of intervals, and then we update current interval to point to the interval pointed by this variable interval and move on. Using this approach, our time complexity is going to be O of n time and our space complexity is going to be O of 1. So now let's try to understand the coding implementation for this problem. This is what our code is going to look like. So here in our coding implementation, we first define the resulting list, and at the end of the function, we convert our array list to an array and return it. So as discussed from our algorithm walkthrough, we are going to need 2 variables. So initially we create our current interval variable and assign it the value of new interval. And in our iteration over intervals array, we use interval variable which points to intervals I. So here I am simply using for each loop where this interval variable is pointing to our current interval. So initially it is at the interval which is at index 0. We can first create current start and current end values and set it to the start and end values of our current interval. And next we are going to check for 3 conditions. So the first if block is for the case when our current interval, this one assigned here, comes before our interval, and if that is the case, then we simply add current interval to our list and we set current interval equal to interval and move on in our iteration. And the second condition is when our interval comes before our current interval, then we simply add that interval to our resulting list and move on to the next interval. And the third condition is the case when there is an overlap between current interval, and in that case, as discussed, we have to update the start and end values of our current interval variable and then move on to the next interval. And once we are done iterating over all the intervals, we are going to be left with current interval, and at the end we simply add that current interval to our resulting list, and at the end we convert this list to an array because the function signature requires us to return an integer array instead of a list. So that is why we have to convert this list to an array and we would be done.